Math is magic. Have you ever heard that quote before? Stick around, and in this video, you'll see a real example of why it's true. Hi everyone, and welcome to the Problem Solving channel. If this is your first time here, let me introduce myself. I'm a software developer just like you, passionate about competitive programming. My ultimate goal? To reach the red rank on Codeforces. And this channel is my journey toward that dream. If you share the same goal, then let's achieve it together. Don't forget to like, share and subscribe to stay updated. Now let's dive into solving this problem. Today's problem is called calculating function. It's problem number A486 on Codeforces. Let's start by understanding what the problem is asking us to do. We're given a single input, n, which is a number between 1 and 10 to the power of 15. The goal is to calculate the sum of a sequence that follows this specific pattern. Al, -1 plus 2 minus 3 plus 4 minus 5 plus 6 and so on, alternating between subtracting odd numbers and adding even numbers up to n. Tandi. Our task is to find the total sum of all the numbers in this sequence efficiently, even for very large values of n. Let's start with an example. Suppose our input is 4. What does that mean? It means we need to sum the following sequence of numbers. -1 plus 2 minus 3 plus 4. Now let's calculate the sum step by step. -1 plus 2 equals 1. 1 minus 3 equals -2. -2 plus 4 equals 2. So the final result is 2. As we can see, the answer for this example is 2. By now, you should have a clear understanding of what this problem wants. Take a moment to pause the video, think of your own solution, and try solving it. Once you're done, come back and continue watching to see my solution. If you have a better approach, an alternative solution, or any suggestions to improve my method, feel free to drop them in the comments. Let's discuss and help each other level up our skills. We could solve this problem by using a basic for loop, iterating from 1 to n and applying a function to check whether each number is odd or even. If a number is odd, we would multiply it by -1. If it's even, we would leave it as is. Then we'd add all the numbers together. But we're not going to do that today. Instead, we'll use some math magic to solve this problem more efficiently. What if we simply sum all the even numbers together, sum all the odd numbers together, and then subtract the sum of the odd numbers from the sum of the even numbers? Wouldn't that achieve the same result? Let's test this approach with our example. If the input is 4, we first sum all the even numbers between 1 and 4. The even numbers are 2 and 4, and their sum is 6. Next, we sum all the odd numbers. The odd numbers are 1 and 3, and their sum is 4. Now, subtract the odd sum from the even sum. 6 minus 4 equals 2. And there we have it, the same answer as before. Now that we understand the approach, pause the video and try writing the code yourself. When you're ready, resume the video to see the solution. Welcome back! I hope you tried writing the code. If you did, take this time to compare your solution with mine. If you didn't, no worries. Just follow along as I explain my approach. If you're good at math, you'll know that summing all the even numbers up to n can be done using a simple formula. The formula is the count of even numbers in the range multiplied by the count plus 1. Similarly, the sum of all odd numbers from 1 to n is the count of odd numbers in the range raised to the power of 2. As you can see on the screen, here are these two formulas. 1. Sum of evens. Count of evens multiplied by count plus 1. 2. Sum of odds. Count of odds raised to the power of 2. Now let's use these formulas in our code. First, we need to count all the even numbers in the range. If the range is from 1 to n, half of the numbers are even, and the other half are odd. To calculate the count of even numbers, we simply divide n by 2 using integer division, which gives us the whole number without any remainder. For example, if n is 5, how many even numbers are there? Only 2. Those are 2 and 4. The last number in the sequence determines how many even numbers exist, which is why this formula works. Now, when counting the odd numbers, we need to check if n is odd or even. If n is even, the count of odd numbers is exactly the same as the count of even numbers, which is n divided by 2. But if n is odd, we divide n by 2 and add 1, since the last number in the sequence is odd. For example, if n is 5, there are 3 odd numbers: 1, 3, and 5. Next, let's apply our equations. The sum of even numbers is the count of even numbers multiplied by the count plus 1. The sum of odd numbers is the count of odd numbers raised to the power of 2. Finally, we subtract the sum of the odd numbers from the sum of the even numbers. This gives us our answer, which we can then print. And that's it. We've successfully solved the calculating function problem using the power of math. Isn't it amazing how math simplifies what would otherwise be a complex and time-consuming task? Instead of looping through all the numbers, we used formulas to calculate the result in just a few steps. Math truly is magic. It turns problems into elegant solutions. If you've enjoyed this journey and learned something new, make sure to like the video, share it with others, and subscribe to the channel to join me on this exciting path of competitive programming. Also, don't forget to leave your thoughts in the comments. Whether it's a suggestion, an improvement to the code, or just your experience with the problem. Together we'll keep leveling up and making progress. Thank you for watching, and I'll see you in the next video.